All right, our first test is coming up. This is the review for it. The 30 problems in this review are first cousins to the problems you will see on your test. If you can work these problems, you will be able to do well on your test. If you find a particular problem challenging, its section number is included so you can go back and do some more preparation. Let's see what happens when we try to work these 30 problems together. Let's see if there's any difficult problems. Let's see if what the time is. Remember, you will have 90 minutes, 90 uninterrupted minutes, which means once you start, you may not stop. Once you start, the clock is ticking and you have 90 minutes until the test must be finished. The test will become active on Friday morning at 8 o'clock, and it will end Sunday night at midnight. So do not wait until the last minute to do your test. All right, let's see what we got. Solve the following linear equation. Obviously, first thing I need to do is sum distributive. I have my calculator handy. Make sure you have your calculator handy as we work these problems. Seven times 25 is 175, I think. Negative times a negative. Here's where some of you may make an executive decision and decide, I think I'll put my W's on this side since there are more W's. So subtract 24W from both sides. Want to get the W by itself, add 175. If you have difficulty combining positive and negative numbers, let your calculator do it. Negative 30 plus 175 turns out to be 145. That's my W. Now keep in mind that sometimes, in fact most of the time, Hawks will have something like this. W equals. So do not put in the box W equals 145. It'll count it wrong, even though you got the wrong answer. Look at how it's expressed. Make sure you answer as Hawks is asking. W is 145. So whatever the expression is, make sure you answer the question as Hawks is asking the question. All right, solve the following. Some more distributive. Like terms. (16 minus 11 is 5. Subtract 4x from both sides. Oh my goodness, look what happens. My x's disappear. How do I solve it if my x's disappear? All right, you might remember that there are 3 things that can happen when I solve an equation. The first is called conditional. That's when I get an answer like W equals 145. The second is called a contradiction. That's when my variables disappear. And I get a false statement. For example, 5 equals 7. When this happens, I conclude there is no solution. Nothing works. The third thing that can happen is called an identity. That's when the same things happen, the variable disappears, except I get a true statement. Like 5 equals 5, as in this case. What I conclude there is that everything works. There are an infinite number of solutions. Solution set is all real numbers. Every single real number satisfies this type of equation. All right, keep this. By the way, I will send this to you, these actual sheets, so you can have these notes and these problems before you as you take your test. All right, solve the following for r. In other words, get r by itself. Right now, r is being multiplied by 2 and pi. The way we undo a multiplication is through division. Divide by whatever is multiplied by the r. Oh my goodness, that was easy. R equals c over 2 pi. No problem there. Find 3 consecutive integers whose sum is that. All right, here are my 3 consecutive integers. And you remember, consecutive means in a row. This is something like 27, 28, and 29. Obviously, those are not the numbers because they don't add to that. Hey, how do I find my 3 consecutive integers? The strategy we used in our video was to take this sum, divide it by the number of numbers I have here. Let's see what I get. 462 divide 3 is 154. That's the average. That's how you average things. That's the average of these 3 numbers. Now, you know the average is going to be the middle number. So if that's the middle number, that's the largest number, that's the smallest number. Again, answer the question that Hawks is asking. Is it asking for the smallest, the largest, all 3? Make sure you note what Hawks is asking as you answer it. Once again, if it's 5 consecutive integers, you're going to divide by 5. Remember this, though. If it's 4 consecutive integers, you're still going to divide that number by 4. And whatever you get here is going to be in between your 2 middle numbers. It's not going to be one of your numbers. It's going to be in between. It's going to be something and a half. So it's going to be in between these 2 numbers. So our strategy remains the same. Take your total, divide it by however many numbers you got. That will give you either your middle number or the middle of the numbers. But after that, you can work out as to what it is. If this happens to be 46.5, why this must be 47, this must be 46, and so forth. All right. Cartesian coordinate system problems. Identify the quadrant or axis on which the following point lies. Remember, if it's an axis point, one of these is going to be 0. So use your grid, your rectangular coordinate system. Let's see, -4, -6 is over here. 1, 2, 3. This is the 3rd quadrant. So my answer to the question is 3rd quadrant. All right, still with the rectangular coordinate system. Consider these 2 points. Find the distance between them. You have a formula for the distance. It goes like this. Distance is the square root of x2 minus x1 squared. y2 minus y1 squared. What's x2 and x1 and all this stuff? Well, I have to label my points. I have to call one of them x1, y1. Call one of them x2, y2. Doesn't matter which one. Then I have to fill in the blanks. Okay, this is x2 minus x1. Let's see, that's 7 minus a -1 squared. Don't forget to square it. Plus y2 minus y1 is 5 minus a negative 9. Again, squared. Don't drop a negative here. Minus a negative is going to be positive, so this is 7 plus 1 squared. This is 5 plus 9 squared. That's 8 squared. That's 14 squared. So that's 64. 14 squared is 196, I believe. Let me check. It is. Plus 64 is square root of 260. Now here's where you might want to look at your instructions. If it says find the distance, that's it. Square root of 260. Because you can check it out. 260 does not have a perfect square. If it says simplify, I'm not sure it does or not. If it says simplify, you're going to have to see if this guy will simplify. And the way you do that is you use your old factor tree. This is an even number, 2 times 130. This is an even number, 2 times 65. This is divisible by 5, 5, and 13. So 260 can be thought of as 2 times 2 times 5 times 13. And anytime something shows up twice inside the radical, you bring it out of the radical once. So this is 2 square roots of 5 times 13 is 65. If they ask you to simplify, this is what you do. If they don't say simplify, this is your answer. All right, find the midpoint. Again, of these two lines right here. We have a midpoint formula. And remember, the midpoint formula is the formula to find a point, the midpoint. So it has an x-coordinate and a y-coordinate. The x-coordinate is the sum of your x's divided by 2. In other words, the average of your two x values. Add them up, divide by 2. The y-coordinate is the average of your two y's. Add them up, divide by 2. Hey, that's pretty easy. So it's negative 1 plus 7 divided by 2. It is negative 9 plus 5 divided by 2. That's 6 over 2. That's negative 4 over 2. So my midpoint is 3, negative 2. Again, midpoint formula, distance formula. Have these guys highlighted so you can refer to them when you need them. All right, consider the compound inequality, sometimes called a double inequality. You see why? It's got two inequality symbols in it. First thing it says is solve and express your answer in interval notation. All right, solve means get the z by itself, so let's do that first. Let's add 3, not to both sides, but to all three parts. I get 0. That's 4z. 16. Divide by 4, and I'm finished. And I find that 0 is less than z is less than or equal to 4. And what this means is z is in between 0 and 4, including 4. So you don't have to do this, it doesn't ask for it, but the best way to get the interval notation is to look at a number line. So 0 to 4. It's everything, z is in between 0 and 4, so it's all this stuff right here. Now I gotta have ending markers. Is 0 included? No equal to sign there, so no, it is not included. Is 4 included? Equal sign there? Yes, it is. That's the difference between a parentheses and a bracket. No equal sign, parentheses. Equal sign, bracket. And how do I write this in interval notation? Just like that. Parentheses, 0, all the way to 4, bracket. So this is what they're asking for when they ask for interval notation. All right, graph the solution set. Hey, we just did it. Everything in between. Make sure you put your bracket and your parentheses, because that's going to be the difference in it being right or wrong. Do you get the correct ending markers? All right, consider this compound inequality. Solve and express it. Now, when I have a fraction, my two-step process is number 1, find the greatest common, or the LCM, I'm sorry, the LCM, the least common multiple of my denominators. I want to find the smallest multiple of 4 and 2. And when I think about it, 2's multiples are 2, 4, 6, 8, 10, etc. 4's multiples are 4, 8, 12, etc. The smallest common one is right there. Common means they have it each in each list. So 4 is my LCM. Why do I need that? For step 2. Multiply each term by the LCM, which of course is 4. So I'm going to multiply each part by 4. Why? To get rid of my denominators. I don't want these fractions. Thank you very much. So instead of multiplying by 4, I'm going to put it over 1 since I'm multiplying fractions. Now, once again, do not multiply your tops. Do not multiply your numerators. Let your denominators cancel. 4 cancels with 4. 4 cancels with 4. 2 will go into 4 2 times. So look what I have over here. Just 10. A little distributive, 2y plus 6. Only thing I have over here is 20. Hey, now this looks just like this, doesn't it? Get the y by itself. Minus 6, minus 6, minus 6. Divide by 2, and I got it. All right, so, and it says in interval notation, let's do the number line first. So here's 0, 2, and 7. Y is anything in between 2 and 7, so it's all this stuff in between 2 and 7. Infinite number of points here. Do I include my endpoints? I do not. No equals to sign, so I got me some parentheses. And this is my indicator of what the interval notation will be. Parentheses from 2 to 7 parentheses. Again, make sure you note if there is a equal sign for a bracket to be included. So far, so good. All right, is the following linear or not? Linear equations have x's, y's, and numbers. Something like 3x minus 2y equal 117. X's, y's numbers. They do not have things like x squareds, square roots of x's, xy's. This is my problem that makes me answer no. This is not a linear equation. All right, consider the following equation. Got it? Find the x and y intercepts if possible. Now remember, to find an x-intercept, I let y equal to 0 and solve for x. So in this equation, to find the x-intercept, I'm going to let y equal 0. So I got 2 times 0. 2 times 0 is just 0. I get negative 5x equals negative 10. I want x, so I divide by negative 5. X is 2. So find the x and y intercepts if possible. X-intercept is good. Now you realize this is a point. I can say the x-intercept is 2, or I can also say it is the point 2, 0. And I'm going to need this information because I need to graph it down here. So the x-intercept, we'll get to this in a second. All right, let's do the y-intercept. To find a y-intercept, I let x equal 0 and solve for y. So in my equation, everywhere I have an x, I'm going to put a 0. That's just 0. So I get 2y is negative 10. Divide by 2. Y is negative 5. And again, this is a point where y is negative 5. So I'm going to, the next, graph my 2 points, find the point 2, 0. I'm going to find the point 0, negative 5. And as I plot those 2 points, the Hawks program will actually draw the line for me. I don't have to draw the line. Hawks will do that for me, but I just plot the 2 points and the line will be drawn. All right. Find the slope of the following line. How do you do that? Well, you put it in the form y equals mx plus b. In other words, solve for y. So I got to solve this guy for y. All right, y's are already over here on the left side. Let's get rid of the x's. So I get negative 8y is, I'm going to put my x's first because that's the way the form is in my slope-intercept form. Not there yet, need to get y. Divide by negative 8. So I get y is 6 over 8, that's 3/4. And I believe Hawks will ask you to simplify that. 3/4 x plus 7/8. Now remember, once I get an equation in the form y equals, the coefficient of my x is my slope, and the constant number at the end is my y-intercept. So it says find the slope. There it is. Slope is 3/4. Got it. All right. Find the equation of the line in slope-intercept form that passes through that point with a slope of 7. Now here's where you can save yourself some time. Look at this point. 0 for an x, 2 for a y. 0 for an x, 2 for a y. This is a y-intercept. Oh my goodness. That means the y-intercept is 2. So I've got the y-intercept and I've got the slope. I've got the equation of the line. Y equals slope times x plus the y-intercept. Y equals slope times x plus the y-intercept. Find the equation of the line in slope-intercept form. Get it. All right. So recognize that if you have a point 0 something, that something is your y-intercept. All right, going on. Consider the following equation. All right, I'm considering it. Express it in slope-intercept form. Notice it has x's and y's. So let's distribute and get everything in good order. -3, -9. -3 times -x. Now, if it's in slope-intercept form, that means I want to have it in the form y equals. So I need to get my y's by themselves. So get rid of this 14. I get 6y equals 14 -9 is 5. 3x, I'm going to put the 3x first because that's the form. Y equals so many x's plus a number, plus my 5. I want y by itself, so divide everything by 6. Y equals 3 over 6 is 1/2 x plus 5/6. There it is in slope-intercept form. So that's my first challenge. Express this in slope-intercept form. There it is. All right. Second question. Find the equation of the line that passes through some random point and is parallel to the line that I just found. Let's remind ourselves that the line I just found is y equals 1/2 x plus 5/6. Express your answer in slope-intercept form. All right. I know this is the line that is parallel to my line, which means the only bit of information I need from this line is its slope. So I know my slope is going to be whatever the slope of this line is, which is 1/2. Why? Because parallel lines have the same slope. They're equally steep, equally slanted. So I know my slope, and I know a point. Let's look at the form y equals mx plus b. I've got the slope, but look here. I've got a point, x and y, x and y. So I have the slope, I got an x, I got a y, I've got everything but b. So all I need to do is fill in these two values for x and y, this value for m, and find out what b is. Here we go. Here's my y. -4 equals the slope, 1/2, times x, which is -5, plus b. So I get -4 equals -5/2 plus b. Got to get b by itself here, so add 5/2. So I get b is -4 plus 5/2. Might be wise to get -4 in terms of halves, so we can combine these two fractions easily. -8/2, 8 over 2 is 4. The way you combine positive and negative numbers is you subtract and take the sign of the larger. So b, it turns out, is -3 over 2. All right, look what I got. Got the slope. Got the y-intercept. That means I got the equation of the line. Y equals m x plus b. Ta-da. Express your answer in slope-intercept form. We did. All right, consider the graph of the following relation. Just a bunch of points, a whole bunch of points. First of all, it says find the domain and range. Now, when I'm looking for the domain of a graph, the domain of a graph is the width of the graph along the x-axis. So I use the x-axis to determine the domain of this particular relation. Hey, how wide are the points? Hey, there's no points over here, so don't worry about it. No points over there, so don't worry about it. The points are in between here and here. Let's see, 1, 2, 3. In between -4 and +4, aren't they? The domain, all the x values are between -4 and 4. Do they include -4 and 4? They absolutely do. There is a point at -4. There is a point on the graph at 4. So the domain is everything from -4 to 4. And my brackets show that there are points at -4 and 4 also. All right, the range of a graph. If the domain is the width of the thing, the range is the height of the thing. And that is along the y-axis. So I say from where to where, and you always start low to go high. So it's from -2 to 2. So my graph goes from -2 to 2. After 2, there's nothing else on the graph. Below -2, nothing else on the graph. So it's from -2 to 2. And I use brackets because there are points at -2 and at 2. Good thing to note. The domain, when you're looking at a graph, is the width of the thing. The range, when you're looking at a graph, is the height of the thing. Okay, so taken care of. B part, determine if it represents a function. Does this represent a function? What do you use to determine if a graph satisfies function definition? Use the vertical line test. Does this guy pass the vertical line test? No, look here. No problem at all to find a vertical line that cuts the graph in 2 places. This guy fails the vertical line test, so my conclusion is not a function. If you had something like a parabola that passes the vertical line test, every vertical line only cuts it in 1 place, and you say, yes, that is a function. This guy, sorry, not a function. All right. This is my function notation. Here's a function. F of x is the square root of something x minus 4, and then on the outside of the radical plus 6. They say find f of x minus 1. This is going to be simple. That means everywhere there's an x, I simply put x minus 1. So f of x minus 1 is, everywhere there's an x, I put an x minus 1, and I still put the minus 4 plus 6. And I simplify it, minus 1 minus 4. That's it. That's as much as I have to do. Hey, if it says what's f of 2x? Well, everywhere there's an x, I put 2x. And that's it. What if it said find f of 3? No big deal. Whoops, let me do that. Let me do 5. F of 5. Everywhere there's an x, I put a 5. plus 6. This one I can simplify, because 5 minus 4 is 1. Square root of 1 is 1. No big deal. So when it says f of something, everywhere there's an x, you put the something, and then you evaluate if possible. All right, consider the following function. Now notice this is a quadratic function, squared, right? And this is what's called vertex form. Remember, the graph of every quadratic function is a parabola, either an upward turning parabola if it's positive in front here, or a downward turning parabola if it's negative in front here. But this is in the form that reveals what the vertex is, that point where the parabola stops going down and starts going up. All right, and here's what you do. You simply take the opposite of this number and exactly that number. Opposite of this guy and exactly this guy. So my vertex is, opposite of negative 2 is 2, exactly negative 5. There's my vertex. So when it's in vertex form, boy, that's easy. Just take the opposite of that number and that number right there. There's my vertex. All right, find the X intercepts, if any. Remember how to find an X intercept? You let y equal 0. Hey, wait a minute. I don't see any y's. Oh yeah, I remember now. Anytime I want to, that it's convenient for me, I can substitute y for a of x. So this is the same as y equals x minus 2 squared minus 5. So to find x intercepts, and by the way, this is not just for lines, this is for circles, this is for parabolas, this is for any equation that has x's and y's in it. If you want to find where the graph of that equation cuts the x-axis, you let y equal 0 and solve. All right, here we go. Y 0. Now I want to solve this for x. I want to get x by itself. Right now I got it, this minus 5 here, so I'm going to add 5 to both sides. So I get, I'll put the x term on the left here. X minus 2 squared equals 5. Yeah, I still don't have x yet. I got something squared. How am I going to deal with or undo something squared? Yeah, I got an idea. How about square root? So square root of x minus 2 squared is just x minus 2 equals square root of 5 is just square root of 5, except I need to give myself the option that this is going to, let's see, the vertex of this guy is 2, negative 5. Notice what happens. It cuts the x-axis in 2 places. This plus or minus allows me to enjoy those 2 places, allows me to identify those 2 places. So when you take this square root, make sure you put plus or minus so you can have the 2 x-intercepts. I'm not finished yet. It doesn't say x equals. So here I got it. X is 2 plus or minus square root of 5. Now, I'm not sure how Hawks is going to express as ordered pairs. There we go. So now we know how it's going to ask. Express this as an ordered pair. This is my x, and my y, of course, is 0 when I have an x-intercept. So I have 2 plus square root of 5, 0, and 2 minus square root of 5, 0. In my mind, this is the toughest problem in the whole test, finding the X intercepts here. So you got to go through some steps. You have to remember your plus or minus. You have to express it as ordered pairs. But here's my answer. All right, oh my goodness, there's a C part. So it says find 2 additional ordered pairs on the graph. Let's go back and look at our original equation. And I'm going to put in the form y equals because I'm going to have to find ordered pairs. Y equals x minus 2 squared minus 5. That's my equation. I need to find some x's and y's. This is where I create a little grid. Notice it says additional, so I can't use the ones I already have. So what do you want to pick for x? How about 0? I'll pick x, 0 for x. So y equals 0 minus 2 squared minus 5. That's negative 2 squared minus 5. That's positive 4 minus 5. It's negative 1. So if I pick 0 for x, I get negative 1. All right, let's pick something else for x, like 2. Nope. Yep, how about 2? Something easy. 2 minus 2, that'll be nice. Y equals 2 minus 2 squared minus 5. Y equals 0 minus 5. It's negative 5. So here's my 2 additional ordered pairs. 0, negative 1, 2, negative 5. Again, you can pick anything you choose, anything you want. Just make it easy on yourself. All right, graph the parabola. All right, let's see. I've got a vertex, right? Vertex is at 2, negative 5. 1, 2. 2, negative 5. Hey, I know it goes to the point 0, negative 1. And it goes to the point 2. Oh, I just found this is not an additional point, is it? Sorry, this would not count because it's already one of the points that I have. That's my vertex. So let's pick 3. 3 minus 2 is 1. 1 squared is 1. 1 minus 5 is negative 4. So 3, negative 4. So here goes the parabola. And again, once you put these points in there, we know from our finding the X intercepts that this is 2 plus the square root of 5 right there. And this is 2 minus the square root of 5 right there. But I wouldn't put those in. Use points that are easily graphed. And once you graph some points, Hawk's program will graph the rest of the parabola for you. All right, here's one of our max and min problems. Maximize or minimize a function. This says total revenue is given by this function. Revenue of x, R of x, is 700 times x minus 0.5x squared, where x is the number of rooms rented. Now, recognize what this guy is. This is a quadratic function. And as a quadratic function, it is either an upward turning or a downward turning parabola. Can you tell which one? Look at the sign of the coefficient of your x squared. This tells me I have a downward turning parabola. What we call in the trade a frowny face parabola. Downward turning parabola. So whatever this guy looks like, it's downward turning. Okay, I'm not sure, I'm just guessing where it's going. So, but it's downward turning, which means it has a maximum point. And I can find the x value for that maximum point with a very simple little trick. Do you remember what it is? It's negative b over 2a. This is going to be the silver bullet for solving the problem like this, which means I have to figure out what the heck b and 2a are. What's a and b? Well, remember, a is the coefficient of your x squared. So in this case, it's negative 0.5. B is the coefficient of your x. It's 700. And C is the constant number at the end. There wasn't one there, so let's just say it's 0. Well, we actually don't even need C, do we? So the x is going to be the negative of b. B over 2 times a. So it's negative 700 over 2 times negative 0.5. You can do this in your calculator if you want. You'll find out it's negative 1. Hey, check it out. I got a negative and a negative. That's a positive. 700 over 1 is 700. And there's my answer. What number maximizes the revenue? 700 is the x that maximizes the revenue. 700 is the number of rooms rented that maximizes the revenue. All right, but here's the silver bullet right here, negative b over 2a. Make sure you got it in the right order. If you did it in this order, it'd be you'd have the a and the b mixed up. Make sure your x squareds go first. Make sure you put it in standard form before you identify the a, the b, and the c. All right, consider this function. H of x equal 9/8 times the absolute value of x. What is this function's general shape? Now, each of you should have handy the shapes of the 9 basic functions. I provided this for you. Make sure you have this handy because all you're going to do is look for the absolute value of x. And please notice the number in front is positive, which means it's still an upward turning v. If that number happened to be negative, it would be a downward turning v. So you're going to look at all the shapes that are offered to you. It's going to give you like 8 different shapes. It's going to say which is the general shape of this particular function. Why, it's this guy right here. That's the graph you choose. But again, have the shapes of the 9 basic function sheets handy. I will, in fact, locate mine and attach it to this for those of you that haven't run it off yet. All right, find 2 points other than the origin on this particular graph. Again, if I'm looking for points, I'm not going to express it as h of x. I'm going to express it as y equals 9/8 times the absolute value of x. And let's make it simple. Can't choose the origin. Can't choose 0 for x, but I can sure choose 1. Y equals 9/8 times the absolute value of 1, which is 9/8 times 1, which is 9/8. 9/8. How about if I pick -1? Y equals 9/8 times the absolute value of -1 equals 9/8 times 1, which is, goodness, it's 9/8 again. That was easy enough. But just pick something easy that will allow you to evaluate this function, the absolute value function, and multiply it by 9/8. All right. Find where the following function is increasing, decreasing, or constant expressed in interval notation. All right, here's where you're going to have to realize that something has been transformed. I have a general shape, right? This is absolute value. Here's my general shape. But it's been transformed. Look here. I have a horizontal shift. Now here's where I have to remember that it's the opposite of what you would think. If I have a +4 added in, if I have a 4 added inside the operation itself, +4 means a horizontal move to the left. Yes, it does. X -4 would be a horizontal move to the right. So this is a horizontal shift 4 to the left. This is all the information I need to know what the increasing, decreasing, and constant intervals are. Here's why. The 3 stretches the thing out. It makes it a little bit thinner, but it still doesn't change the fact that this part is increasing and this part is decreasing. All right. Once I have it sketched, once I have a picture of the thing, and the horizontal shift is the only thing I need to keep in mind, where is it increasing? Where is it decreasing? Remember, we're looking as we're moving left to right. As I'm moving left to right, this part of the graph is decreasing, isn't it? This is decreasing. It's going down. And it's going down all the way from -infinity all the way to 4. Now I want to express the decreasing aspect or the decreasing interval in interval notation. So decreasing from -infinity all the way to 4. Remember, I always put a parentheses with my infinity symbols because it's not a number that I'm including. It's a concept. All the way to 4. Now, ladies and gentlemen, here's another place where you're going to get, where a little insight is going to give you the correct answer. Since 4, it appears, is part of both the decreasing and the increasing interval, I do not include it in either interval. This is a turning point. Stops decreasing, starts increasing. So I always have a parentheses to show that 4 is not part of the decreasing or the increasing interval. The increasing interval, again moving from left to right, is from 4 all the way to infinity. And since 4 is a turning point, I do not include 4 in the interval. So this took a couple of insights. First of all, it said, what's the shape in general? All right, it's an upward turning V. And notice positive, so it's upward turning. There's a horizontal shift, 4 to the left, so I had to move the graph 4 to the left before I decided what's decreasing and where is it increasing. All right, this one's easy. Consider the following function. What is the basic function? Again, you got your basic function sheet. Can you look at the function sheet and see what's been transformed? Why, it's pretty easy. It's f of x equals x cubed. That's all you got to put. So the basic function that has been transformed is y equal x cubed, or f of x equal x cubed. All right, what's the basic shape of the function? Hey, you got your function sheet handy? Check it out and find the one that looks like x cubed, which looks like that, and that's the one you're going to pick. So it looked hard, it's not. Find the basic function, find the basic shape. All right, greatest common factor. We just did this recently. You remember, good way to do it, break it down into prime factors and then see what they have in common. 14 breaks into 2 times 7, an x and a y. Hey, literally, what do my two lists of factors have in common? Well, they got a 2 and they got a x. That's it. So greatest common factor, 2x. Again, greatest common factor of 44 and 21. All right, let's factor these guys out, list their factors. 44 is 4 times 11, but 4 is 2 times 2 times 11. There's the prime factors. 21 is 3 and 7. Look for what they have in common. Nothing. They have nothing in common. What do I put for the greatest common factor if they have nothing in common? Greatest common factor is 1. So if they have nothing in common, if they were what are called mutually prime, no factor in both of them, I should say, nothing in common, then simply put 1. All right, factor if possible. This is where we're going to use the AC method. A, B, C. Remember this? So A equals 4. B is 25. C is 6. Let me remind you of the AC method. Step 1. Multiply A times C. I bet you can handle that without even a calculator. 4 times 6. All right? We multiplied A times C. Second step. Here's the one where you have to actually use some mental calories. Find two numbers whose product, that means multiplication, is AC and whose sum that means addition, is B. And B happens to be 25. So I'm looking for two numbers whose product is 24 and whose sum is 25. Don't start considering the sum. There are an infinite number of sum possibilities with whole numbers. There are a very limited number of products with whole numbers. So start thinking of things that multiply to give 24, like 1 times 24. I think we got our answer. 1 times 24 multiplies to give 24 and adds to give 25. Hey, that's it. That didn't take us very long at all. The very first thing we thought of works. So here's what we're going to do. We're going to use the leading coefficient and our two numbers to build two binomials. And by the way, ladies and gentlemen, if you want to take it another way from what I'm doing here, once you find the 1 in 24, help yourself, like the grouping method, if you want to use that, which is another of our sections. If you want to use the grouping method, that'll work also. Help yourself. But I'm just going to show you here. Using 4t in both my binomials, use the leading coefficient and our two numbers, and that's positive, to build two binomials. Final step, factor out and discard, that means get rid of, any common factor. See anything common to these two? No. See anything common here? Yeah. 4 will go into both these guys. So I'm going to factor out the 4 and discard it. This, ladies and gentlemen, is my factorization. 4t plus 1 and t plus 6. Again, that's the AC method. Now, some of you guys might want to try using the hit and miss, trial and error method, or the factoring by grouping method. Either of those methods will work. This is just an option. All right, factor if possible. First thing you're going to notice, 1, 2, 3, 4 terms. 4 terms is my big hint that I'm going to use factoring by grouping. So step 1 in factoring by grouping, I group my terms into pairs because of something they have in common. Hey, these two guys have B's, these two guys have Y's, so I'm going to be pairing them, BQ plus BW. And I'm going to separate them just to show you that I'm thinking of them as pairs of terms. Step 2, factor out any common factor. These guys have a B in common. Let's factor it out. These guys have a Y in common. It's a plus, so I'm going to put plus. When I factor out the Y's, I get Q plus W. Now, here's what you should notice when you are using factoring by grouping. These parentheses must be the same. These two binomials. Otherwise, you can't go on to your final step. Final step is factor out the common binomial. So I factor out the common binomial. I keep it in parentheses. It's a quantity by itself. Anytime I factor out a common factor, I'm going to have parentheses. When I take out the Q and the W, what's left? B plus Y. This is when you're finished factoring by grouping, when you have a binomial times a binomial. Again, 4 terms, think factoring by grouping. All right, you're going to have a problem like this. You might notice what it is. This is the difference of 2 squares. Difference of 2 squares factors wonderfully, conveniently into 2 binomials. I take the square root of this guy here and here. Square root of 25x squared is 5x. And I take the square root, this guy, here, and here. Square root of 4 is 2. And my signs in between my binomials, always one of each, plus and a minus. So that's it. Square root, plus and a minus. All right, consider this polynomial. Notice it has 1, 2, 3. It's got 4 terms. First of all, it says express in descending order. That means descending order of exponents. This is what is also called standard form. If it's in standard form, the exponents are going downhill. So let's put the largest exponent first. Then 11. Then 9. And I got this lonely little 2 there. So that's the first challenge. Express in descending order. Done. Identify the degree. Remember what the degree is. That's the largest exponent. Largest exponent. It's not 7x to 13. It's not x to 13. It's 13. So the degree is just the exponent that's the largest in this particular polynomial. And finally, identify the leading coefficient. That's the number, the coefficient, in front of your leading term. So it's not 7x to 13th, it's not 7x, it's just 7. You put 7x to 13th, it's going to count it wrong. You put 7x, it's going to count it wrong. Just 7. All right, factor if possible. Now, I don't have to use the AC method here since there's not a number other than 1 in front of y squared. Just 1y squared. So I simply ask myself the question, what 2 numbers? What 2 numbers? Multiply to give negative 15 and add to give two. This is my C, this is my B. What 2 numbers? Multiply to give C, add to give B. And notice, multiply to give a negative number. How does that work? Well, it means I have to have 1 positive and 1 negative. So let's start making some suggestions. 1 and negative 15. Those 2 multiply to give negative 15. Likewise, negative 1, 15. How about 3, negative 5? Or negative 3 and 5? Hey, that's about it. Those are the pairs of numbers that multiply to give negative 15. Here's the question. Does one of those pairs also add to give a positive 2? Yeah, that one right there. Now see, it didn't take me long. It took me about 17.3 seconds to write down these 4 possibilities. So write them down. Give yourself that option. And then look for a pair that meets both conditions. Multiplies to give negative 15. Yep. Adds to give a positive 2. Yep. So here are my 2 binomials. Minus 3 plus 5. Finished. Factor if possible. It's possible. There it is. Next, factor out the greatest common factor. So here's what I want to ask myself. I want to look at 3 different things here. Number 1, the coefficients. Number 2, the x's. Number 3, the y's. That's it. So to take out the greatest common factor, I could list these out and find the greatest common factor like we did earlier. Or I could simply ask myself these questions. Number 1, what's the largest number that will divide evenly into 4, 6, and 4? That would be 2. 2 is the largest number, the greatest number that will divide into both 4, 6, and 4. All right, they all have x's, right? They each have at least 2 x's. That one's got 2, that one's got 3, that one's got 4. They have at least 2 x's. Another way to think of it is the smallest power of x. The smallest power is x squared. So that's part of my greatest common factor. And finally, y's. The smallest power of y is that one right there. It's not even existing. So I do not have a y in my greatest common factor. Take out a greatest common factor. Always going to be parentheses. All right. 2x squared times what gives me this? I need another 2 to make the 4. I need another x to make the x to the third. And I need a y, don't I? And take 20 seconds and multiply 2x squared times this and see if it gives you that. It does. Finally, next, 2 times what gives me 6? That'd be 3. X squared, I already got an x squared, so I don't need anything else. 2x squared times 3 does give me that. Finally, 2 times 2 is going to give me the 4. I got x2, I need x4, so I need 2 more x's. I don't have any y's, I need a y, so I need 1 more y. Again, multiply that times that to see if you get that. There's the greatest common factor factored out. All right, dealing with complex numbers, simplify the following. If you've looked at the video, you will know that these are complex conjugates. And I know that complex conjugates will multiply to give a purely real number. No more i's. So here we go. We're going to treat the i's just like an x, just like it was a variable. I have 2 things times 2 things. That means FOIL. So 4 times 4 is 16. 4 times 5i. Negative 5i times 4. And this is what we're going to find out with conjugates, is that the middle 2 terms are always opposites and will cancel. Negative 5 times 5 is negative 25. I times I is I squared. Okay, we're not finished. Got some work to do here. First of all, the middle 2 terms are opposites. They cancel. So I get 16 minus 25 I squared. But keep this in mind. I squared is never in a final answer. I squared, by definition, working with complex numbers, is negative 1. So everywhere there is an I squared, I'm going to substitute negative 1. Negative 25 times negative 1 is positive 25. Look at there. A purely real number. Multiply complex conjugates, you get a purely real number. You always get something plus something. If you get a minus something here, you did something wrong, because that negative 1 will always change this sign to a positive. All right, finally, I to the 169th power. Oh my goodness, how am I going to find that out? Well, it's from this observation. When we started detailing what I to certain powers was, we found out that I to the first is just I, no surprise there. That I squared was negative 1. That I to the third is just the product of these two. I2 times I1, negative 1 times I is negative I. And that I to the fourth would just be I squared times I squared. Negative 1 times negative 1 is 1. These are the bits of information you're going to need to evaluate I to any power. To any power. And here's how you do it. You take the exponent and you divide it by 4. So 169 divided by 4. Let's see what happens. 4 times 4 is 16, 0, 9, 2 times 4 is 8. 1 remainder. I get a remainder of 1, so that tells me that I to the 69th is the same as I to the first power. If you get a remainder of 1, I to the first. So I to the 169th is the same as I, since I to the first is I. What if I had I to the, let's see, 43rd power? Well, just divide this by 4. The remainder is 3. That tells me that I to the 43rd is the same as I to the 3rd. I to the 3rd is negative I. Negative I is my answer. You getting this? So whatever the remainder is, that's the equivalent. And these are the only 4 possibilities. So have this handy to work this problem. By the way, if you're dividing with your calculator, it won't tell you remainder 1. This will be a point, since you're dividing by 4, this would be a 0.25 remainder. This would be a 0.50. This would be a 0.75. This would be a 0.00. So if it comes out even, it's going to be 1. All right, let's see how long that took us to do the test. 76 minutes, but that was with plenty of explanation in addition. So hopefully you will have plenty of opportunities to take care of this. Anything else I need to tell you about this review? I would suggest you run this off and have it handy, and I will include the basic shapes of the 9 basic functions with this. For those of you that do not have that handy, have your calculator handy, and good luck. It's going to be Friday from 8 in the morning through Sunday at 11:59 p.m. midnight, basically. All right, good luck.